We have a MacBook Pro. It's a 15 inches. This is A1990. It's A1990. This is the models between 2018 and 2019. This was actually discontinued. 2019 was replaced with the 16 inches. Uh, and then yeah, so for the pros, Apple actually stopped making the 15 inches in 2019. So they then started to make the Intel 16 inches, and then they made the 13 inches, the 14 and the 16. So the 15 inches was discontinued on the Pro lines. Up until now, Apple do not make 15 inches of the Pro lines. They have a 15 inches on the Air. So the last 15 inches they made was the A1990, and right now they only have 14, 13, and the 16 inches. And the most commonly sold. I mean, the A1990 was a popular machine back in the time. But yeah, so it was discontinued, and this is coming in for no power. In 1990 are very common for you see 9081 failure, which would either fail in itself or would also damage the SSD. So let's quickly take the board out, take the backup out to see what is going on. And then, as you know, we always do not advise that you connect power to the device unless you confirm that it is safe to do so. Okay. First thing we're going to do is to disconnect the battery. Ah, let's see. So usually what I want to do is I want to look at U9080. I want to see what the side of U9080 is looking like. So, and also, so if that is fine, then I'm a little bit less worried about the client's data. But if that is blown, then most likely 12 volt has gone to the client's SSD. So the first thing we want to do is we want to see if we have a short on our PP bus, and it's like the most commonest thing you want to check on the board, and we can check on the PP bus rail short using the two fuses here. So let's have our multimeter. It's set to continuity mode. We're going to have a black probe. This can serve as our ground, and then our red probe. And we don't have a short. Okay, that's good. Now we don't have a short on our bus. Now let's see. What about the 5 volt line? The 2.5, the 2 point. No, that's a PV bus. No, that's not a short. The 2.5 volt. Let's see. Do you have a short there? No, we don't have. We don't have a short there either. Okay. Okay, so that's fine. So we don't seem to have a short, so it's we can connect power to it to see what is it that we are having. So charger is connected. We're expecting to have 12.6 volt on our PP bus. 12.6 volt will mean that we have 20 volt on our PPDC in. Let's see, what do we have? 12.6. Yeah, that means we have 20 volt on our PPDC in, and the machine is starting, and then it shuts down. I guess that's the problem. Is it going to try to start again? It tries to start again, and it shuts down. Oh, I see. So that's the problem. So the machine tries to. So it's like, so okay, I see what the machine is doing. And because this is a design that operates on the auto power on, provided there is power, which this is going to automatically power the device. So it's going to keep trying. So that's the problem. So the device starts and then it shuts off. So the first thing we are going to do is we are going to disconnect all of the cables to see if this is most likely an issue from something connected. So let's quickly take out, we're going to remove the screws and disconnect the cables, leaving just the speakers, and then try again to see if the same thing will, we're not hoping that this is going to be something from, definitely from the DC jack. No, DC jack would not give you an issue like that one. So we are, that's why it's good to connect to kind of guide your screwdriver, because can easily slip off, and imagine if that was close to the battery, could punch a hole on the battery. So what the machine does is it tries to start, but then it goes off. So what we are going to do is we are going to disconnect the cables first to see if it has something to do with the cables. Okay, so let's have cables disconnected. Trackpad cable, keyboard cable, trackpad cable. And by the way, for this design, the fans are connected to the keyboard. So with the trackpad cable, with the keyboard cable disconnected, the fans are no longer going to function. I'm not thinking that the problem might be from the fan, but just because I need the keyboard cable to be disconnected. So we're going to disconnect the screen cable as well. The touch bar cable, even though the touch bar, the point the point the device is starting, it's not at the point where it loads the touch bar yet, but I'm still going to disconnect it. So the device starts and get up onto a stage before the touch bar can be loaded. So I'm going to disconnect that. I'm going to disconnect the power button. Yeah, that can definitely make a machine behave that way. And then now we're going to try again. So most of the mic, now we're not hoping that the mic will be pose any threat. So we leave the speakers still connected. Most of the cables, audio board, power button, touch ID, that's disconnected. Trackpad, keyboard, trackpad, screen, touch bar, even though we're not there yet. Okay, let's try again. We leave the speakers connected. Let's see if the same thing happens. Oh yeah, the fans are not gonna spin now. Oh, okay, we're just gonna use the sound as a. Hmm, that seemed to. So wait. Okay, so we're just waiting for a second time. I mean, the first time, if it's I think the device is on, because I mean we're not getting any secondary chime. The screen is disconnected. Remember? Yeah, so you're not gonna see anything. Okay, I think the device is on. Yeah. So one way we can confirm that is, let's see if we can hook up an external display to it. Now, still having the same problem. Um, I think we're still having the same problem, yeah? Because it just restarted now. Let's give it a bit of time, see if it's gonna restart again. Nothing. But it's not as quick as it. Okay, okay, yeah, but there's something. I mean, the first time it was instant, correct? But now it seemed to. Okay, so let's do this. Let's connect the screen. That way we can tell when it starts and. Alpha. Screen is connected, but there's nothing on the screen. There's no image as well. The screen is connected. Okay. Okay, let's connect the trackpad. Let's connect the trackpad. That way we can tell if there's still power on the machine. So it goes on and immediately it goes back off. So, okay, so let's disconnect the screen and try again. Screen is disconnected. Okay, let's see. No, it still goes off. Okay, it's still off. Let's connect the keyboard. So keyboard is connected. So now we should see the fan spins. Let's see, does it shut off immediately? And it's still on. Okay, it's off. Let's see, and it's off. Okay, so let's see if we hold down the Alt key. Yeah, let's see. Let's see. So sometimes, yeah, let's see if we hold down the Alt key. See if we can get any response from the device. Different response with Alt key. So because sometimes you may have an issue with a NAND chip, and then the device will start, but when it tries to obviously initiate the boot process, it will shut off. So let's hold the Alt key and see if we get anything different. The screen is also connected. We actually have something different. I don't know if you can see that. And that it's yeah, yeah. You might be able to see it. Let's see, like that. No, no, nothing. Is it? And like this? No, just a little bit. That's you see. Okay. So, but you see now it's stable. So if we click on, you see now, so that the device is fine. So this most likely will need a reinstallation of the machine, but then we kind of have, so you see, if I try to initiate the boot, so I'm just going to click on enter, and the device is off. So our problem, it's drive related. So this might just be a case of a crashed drive. So the first thing we're going to do is we're going to try to reinstall the operating system. So it starts again, and then it goes off. That's fine. So we know we are going to reinstall the operating system. But how are we going to do that? Because it doesn't even give us room. So which would then mean that we have to use Apple Configurator 2 to reinstall the operating system. So let us quickly do that. We are going to connect the device to our Apple Configurator. We need the power button to be connected for that process. So we're just basically putting back the cables. Now, because it's an Intel device, we are going to use the left port. The left second port is what we are going to use for your DFU. Okay, so we're going to use this. The left second port is going to be this guy here. If it was an M1, we're going to use the first port because it's Intel. We use the second port. So that's that, and then let's go to an Apple configurator. Now we will have to restore the device, unfortunately, because the files. So it's quickly, yeah, it's going to try to start, but it's not going to start. So we're going to hold Control Alt. Also, it's going to be so we are going to use Control Alt, Shift, and Power. So we're going to hold those four at the same time, and then we count to 1,000, 2,000, 3,000, 4,000, 5,000. Is asking, and then you accept. We are in DFU mode. So what we're going to do is we are going to restore. So we're going to restore because there's no way we can access the drive. So the file is already downloaded, so we are not going to, it's not going to download again. Accept. Now the restore process will definitely erase the files. So accept. When the process is completed, we assume that the problem should be solved because, I mean, this is a case of a corrupted files. So after that is sorted, we now have to worry about the backlight. Sometimes you might also be somewhat related, but yeah, T2 devices can be funny sometimes. So now we still have issues with backlight. So the Apple logo, I don't know if you see that. Yeah, so we have Apple logo now. So we probably have two issues in one. So we have Apple logo now. You can't see it, but it's just there.
Is that the Apple?
Yeah.
Okay, yes, now I see it. Oh, there's a finger mark just next to it.
uh,
Yeah.
so it is loading. So I mean, before now, I mean, as you guys know, the device would not even start at all. So it would shut off. So now the device is loading and it's stable. But the second issue that we now have to tackle, it's the backlight. So and that's fine. It's standard for it to go off. Um, so it should say it's booted, and then afterwards, okay. So we're just gonna wait for it for the process to complete. That's good. When you see that, you should expect a lock sign soon. When you get a lock sign, it tells you that the device is booted, which means the process was successful. Okay, that's beautiful. So the process was successful. So now we can shut off the device. I'm gonna just power and press and hold on the power button until that disappears. The boot shows until it disappears. Okay, now I can put it back on. And I can also kind of just do like a PRAM reset, just you never know, that might help with the backlight. So for PRAM reset, I'm using Command Alt P and R. I don't see nothing yet. You have to be patient for this one. Yeah. Okay, so PRAM is done, and we still have. So right now we kind of have like a flashing folder, I suppose. So we have issues with the backlight. So what we now want to do is see that, yeah. So that's a response to the second. Wait. That's a bit weird because wait. Let's see. Do we have? Oh, okay. The machine is on. So I thought so because of backlight we're having. I suppose now we're having like a flashing folder, but we don't see it because of the backlight issue. Okay, that's fine. Now we have a machine that is working. It no longer shuts down, but we have no backlight. So let us see what is it that we have on our backlight output. So this board is going to be, this is an 820-010. for this guy here, 80.0104 as the guy. So we want to see what is it that we have on our backlight output. Um, so depending on what you have on our backlight output, that will determine what issue, what we need to, the steps we're going to take in resolving the backlight. So so we have our multimeter in voltage mode now. Backlight output we can measure on these caps here. So that this will give us an idea what we have on our backlight output. Full backlight. Okay, first let's just quickly measure that first before we describe or explain that. So let's check here. What do we have? We have 0 volt. Okay, and then so with 0 volt, two things is either the circuitry is not boosting or we have a short on our backlight output. Now if you have 50 volt, so let's go to the schematic quickly. Let's go to some schematic quickly and explain that. Mm, so it's 820.0104. Okay, here you go. Mm, let's see a schematic for this. Okay, let's see. And you are, and this guy here. It is a zero. Let's see. Mm, ah, we're not getting any of its schematic. Okay, so we are just going to quickly use a different schematic because I'm not getting the schematic here, just to get my point across. Let's use a 13 inches schematic. What's happening? I don't see. I'm not getting schematics. I'm only getting both views. Hmm. Okay. For some reason, I'm not getting schematics. I don't know what's happening. So I'm just gonna open from. Let's check our history. So we can check. Yeah, we can check 16 inches. Hmm. Okay, so my machine is doing what it's doing. I'm not sure why it's doing what it's doing. Um, I don't want to be here. Okay, so I'm gonna restart the machine to see what's restart my machine to see what's going on. But nonetheless, so machine is still on. We're gonna go back to that. So what we want to do is we want to disconnect power from the machine now and see why we have 0 volts there. So we are gonna switch our multimeter to diode mode. See what is it that we have on output. For diode mode, you have to have a left probe on ground, and then your red probe is going to be on ground, and then a black probe. That's 0 1. Okay. I actually would like it to have. I actually would like that there's a short on the output because that way the client wouldn't have to replace their screen. So that is my ground, and that is supposed to be my main line for the backlight output. But that is not what it's supposed to be. So what is supposed to be? It's so this is a similar board, red probe on ground and then black probe. This is what you're supposed to get. 1.2. That's what you're supposed to get. But here we are getting funny figures. Uh, Nah, that's not 1.2. So what you want to do when you're so low, you want to disconnect the screen. Sometimes your screen might also be a reason why you have a short on that line, and that's good. The short is still there. It's not a screen issue. It's a board issue. So we are now going to take the board out. Most likely, one of the output caps, one of the backlight output cap, it's faulty. So we are going to find out which one of them is faulty, and then we'll take it up from there. It's time for prayers. After prayer, we will continue. Okay, so we want to quickly take the board out because we want to address the issue of the backlight. So at least the board itself, it's fine now. We just need to address the backlight issue. So let's quickly take the board out to get an idea what's going on the backlight circuitry. We have established that there is a short on the backlight output. So we are going to look out for which of the cap has failed on the backlight output. So usually when you have uh, when you have a short on your backlight output, uh, it's actually very common that one of the caps, one of the output, one of the cap on the output line fails, and then and as a result of that, you have a short on that line. So we are going to check to see which of the cap has failed, and we'll replace it, and that should be it. Okay, let's put the shell on the side. Okay, so the output capacitors, it comprises of 1, 2, 3, 4, 5, 6, 7, and then on the other side you have 1, 2, 3, 4, 5, 6. Let's just confirm that. So these are the output cap. Okay, so this guy is also part of it. So which means you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these are the output caps. So one of those has failed. That is why we are having a low. So put the multimeter back into diode mode. We have our red probe on ground and then our black probe. Let's check again just to be sure. That's 0.0233. That's too low. And the other side is ground. Yeah, so that is low. So you see, it's just confirm. Now on the other side, if you flip the board on the other side, the main line, it's this. This is the main line. That's the main line, and that is ground. So red probe on ground, and then the black probe, we're getting 0. Yeah, and then the other side we are getting. So you see, it's almost as if we're getting the same thing. So it assumes there is a 0 ohm resistor across the line. So let us figure out which of the cap has failed. So what we usually would do, it's what I would do usually, it's I'm just going to take out the whole line to see which of them has failed. So there are other ways you can go about this. You can inject voltage, but this circuitry, it's very contained. I mean, you only have 14 capacitors that are 99% of time, one or two of them has failed. So there is no need to extend, because if you look at it, you only have those cap, and then the other side where you have communication is a cap right by the screen connector cable here, the screen connector the screen connector cable here, and it almost never fails here unless you have a liquid damage. So it almost never fails there. But so what we are going to do is we're going to take out these ones first, and if the short is still there, then we go to the other side to also take out the caps on the other side. So it's most likely going to be one of. Another thing we can also do is we can also take them out one by one and measure to see if the short is out. But I feel like that's going to waste our time. So we can just remove the entire line and then see which see if the short is there. If not, yeah, so that's out. Now let's check to see if we still have the short. Red probe on ground and then the black probe. That's our this is our main line, and the short is gone. So now you see you're having 0 point. It's actually going to keep increasing up until you have 1 point something. So that is good. So what we want to confirm now, it's one of these guys has failed. We are now going to measure across all of the cap to see which of the cap has failed, and then we put the rest back. So we are gonna just do this. Start with this guy here. You see, the one that says OL, that's still fine. The one that you get reading across is the one that has failed. That is fine. OL, that's fine. That is, well, okay. That was fine before it flew off, and that's fine. That's fine. That is fine, and that's our problem. So that's the cap that has failed. I'm not sure if you guys, yeah, that's the cap that failed. So that's the guy. You see on the other side, it looks a little wonky on the other side. You see, okay, I'm not sure if you guys are able to see that, but that's the cap that's failed. Now the rest we have to put, just basically put back the rest. So that one failed. So now we have to put the rest of the caps back. So let's get another one. Just because we need just one more, the one that has failed. Can grab one from here. By the way, these are very common capacitors. You can grab them from any donor. It doesn't matter if it's a 13 inches, 15 inches, or 16 inches. They all use the same cap. Okay, that's okay. That's it. So the next thing we're going to do is we are going to clean that section of the board real quick. Okay, so that's cleaned. The next thing is we are going to put the board in our shell. So this is not part of the issue, obviously, because the board is still powering on. But as you know, C9081. So the best thing you be forced to remove it now before it fails. You can actually see that it's starting to corrode on that side. So before it kills it, the client is before it kills the board, let's rather remove it now. Actually, I feel like that should actually be like a preventive measure on A1990. Even though if you do a repair on A1990, even if you are not directly working on it, you want to check out C9081, because I mean, even if it's not it's not part of the issue that you're having at the moment. You're doing a repair on the board. Chances of it failing down the line, it's like 9/10. So I think the best thing would be just to remove it while you are there, just to help the client prolong the life of the machine. So we are quickly going to connect the cables first. Uh, okay, so let's install the battery screw. Oh yeah, before we do that, let's just confirm that we no longer have a short on the board. So our multimeter is still set to diode mode, our red probe on ground, and then our black probe on the backlight output, which is this side here. And then we're getting 1 point. Yeah, that's good. That's exactly what you're supposed to have. Okay, so now let's start the machine and see what we have. This machine is starting. Want to see fan spin? Okay, fan is starting, and that's a beautiful Apple logo. So we should have a question mark. So that was a question mark that was coming up that we were not able to see. Yeah, so basically there are two issues this machine had. Number one was that the device would, because the files were corrupted, so the device wouldn't start. It tries to start and then it shuts off. So one thing I want to mention, so whenever you have, so depending on where the device shuts off. So remember where I said that the device is not at the stage where it loads the touch bar as yet. So depending on where the device shuts off, that will determine what you want to look at. Now, in this particular case, the device powers on and immediately shuts off. Now, in that case, what you want to do is you want to power the device on and quickly hold down the Alt key. If the device stays without shutting off, then it tells you that the problem is after it's at the initial boot process. So which would then mean that you are having issue with the boot part. In any case, now the boot part that is being selected is the drive. So what you want to do is, unfortunately, situations like that, you have to find a way to do a backup of the files, because you have to reinstall the drive in order for you to be able to use it, which is what we had to do. We reinstalled the drive, the device no longer shuts off, but in addition to that, we don't have backlight. So we had to obviously do a PRAM reset. That didn't resolve it. We measure our backlight output, and then we realize that we have a short on our backlight output. And like I and then one thing with the A1990s, and as well as the A2141s, the 16 inches, is when you have a short on your backlight output, the commonest issue 9 out of 10 of the time is one of the caps, one of the output caps has failed. So what you want to do is you want to take them out. So you can take them out one by one and measure to see if the short is still there, or you can just remove the entire line and then see if the short is there. If not, and then you go to the other side and then you do the same thing. But usually what happens is one or two of the capacitors has failed. And but in situation of in cases of liquid damage, that might slightly be different, because when it comes to liquid damage, you want to actually see what got affected. Then in that case, it might not be the same as scenario. So yeah, that was about the repair. And as you guys can see, the machine starts fine, it doesn't shut down, and then we have backlight. So we are quickly going to put the machine, put the screws back. So we disconnect and then also disconnect. And when you're putting your screws back on the machine, you make sure you don't have power on the board, because you don't want to short out the board. So let's quickly put our screws back. Let's and with the A1990, you find only one screw that is longer than the other ones. Unlike the 16 inches that you have two long, the A1990 only have one longer than the rest, which is going to be here. You know, with the 16 inches, you have additional hole like that on your, yeah. So, but the A1990, you only have one of those. Okay, the P5, T5 are all out. Now we want to go to the T4. Okay, let's use our T5 quickly and T4. See these silver screws, especially the flat ones. You should have five of those. So you have two and then one here. So total should be five. Need one more there. And this is the last one, right? So you should have five of the silver screws. It's important to always know your screws, know where they are coming from, and then where they have to go back to. Where is your phone ringing? Okay. Was the driver for the one that dropped those guitars over the weekend? I think on Thursday. They're supposed to drop. Was it Friday? Should have one more. Okay, let's take from here. Let's see that now. Okay, that's the last one of it. Okay, battery cover. It's the battery BMU cover. This was the screw that we're looking for. Uh, it happens when you are in a hurry to finish up. Okay, and let's put back the pentalobe screws. And so again, while you're doing this, you want to be aware of the screw sizes and designs. They are not the same. The ones you have here, they are the same design, the same length, and the two that you have here are going to be the same thing. Okay, so backlight. This is the okay. That's it. Thank you guys. As you guys can see, the repair is done. I will see you guys in the next one.